we are now coming to a very interesting session about the quantum education and the quantum ecosystem. It's a very beneficial one for enhancing and promoting an ecosystem and educational environment, especially for quantum computing. And our first guest and speaker will be Dr. Ahmed Yunus. So Dr. Ahmed Yunus is a professor of quantum computer science at Alexandria University and Alumni International University. He's the founder and the leader of Alexandria Quantum Computing Group, AliQCG, the coordinator of Q Egypt, Q World Cousin, and the representative of Egypt in the World Quantum Day, and the representative of the Arab states in the International Year of Quantum Science and Technology, IYQ 2025, steering committee endorsed by UNESCO. Welcome, Dr. Yunus. The floor is yours.
Please lower your voice because many people are sleeping after lunch, so we don't want to wake up anyone. Actually, our talk today is scaling quantum education and industry in Egypt. We have word in Egypt لو بطلنا نحلم نموت مش كده؟ So this is how we can enhance or complete the ecosystem in Egypt. We have now community, we have activities, but how can we complete the ecosystem? Actually, any ecosystem has four main stakeholders: government, academia, general public, industry. And I want to take advantage of this special event where all the stakeholders are here in the room. We have government, we have academia, we have general public, and we have industry. So how can we scale what we already have in Egypt in terms of quantum technology? Before we discuss this, so today I'm not going to talk about qubits, I'm not going to talk about superposition or quantum gates. I'm going to talk some strategic talks. So first of all, we have to know what is the activities companies already there are doing. We have quantum sensors, quantum communication, quantum computing hardware, quantum algorithms and application, and of course facilitating technologies. And today I'm going to talk about all quantum science and technology, not only quantum computing or quantum algorithms. This is a distribution of quantum companies. The main activity in quantum software, quantum hardware, and enabling technologies. So we have to remember this picture because we will need it in a minute. Quantum companies per region. Africa is, unfortunately, is the lowest region with companies. That's what I want to discuss to change. If we can, industry should start. This is what we are missing actually in Egypt. This is very important because actually the number of jobs in quantum science and technology is expected to increase very fast, and this is published in a paper, recent paper. The number of jobs in quantum science and technology is expected to increase very soon, so we have to be ready for this. This is a distribution for, this was a study, has been done over 5,929 job posts. What is the requirement? What companies are looking for? So most of these jobs requires people from physics, then software, then engineering. Physics students, you are required. We need physics students, physics graduates, and computer science graduates. These are real statistics from job posts. Actually, many websites are dedicated for quantum job posts now, because the demand on jobs in quantum science and technology is increasing very fast, and but we don't have this in Egypt right now, right? We don't have companies, we don't have jobs, So we have to get ready for this. We have to prepare the ecosystem for jobs in quantum science and technology. Currently, most of the jobs require PhD holders. And actually, no industry can work or can rely on a PhD holders. This is not normal so far. For example, in United States and Canada, 52% of the jobs require PhD students. In Europe, 67% of the jobs require PhD students. This is not normal, right? Usually, jobs require bachelor, then master, then PhD. So the pyramid is flipped. Why this is the case? Because we don't have education in quantum science and technology. We don't have enough degrees in the bachelor level for quantum science and technology. So how can we fix this? Okay, some companies offer a master degree now, offer master degree in quantum science and technology. Some are offering training. Most of them are offering PhD. But this should be corrected. Otherwise, the ecosystem, the industry will not go anywhere. Because PhD degrees is not an easy one. These are technical skills across quantum industry, materials, coding skills, data analysis, laboratory experience, electronics, optics, algorithms, and computer science. These are all mechanics. These are all the skills required for the jobs in quantum science and technology. Most of the jobs are there. Data analysis, materials, and coding skills can come from physics and chemistry, but actually we lack laboratory experience in Egypt. This is one of the problems we have to work on. We can provide all skills. I will show you now statistics that actually all skills are available in Egypt except for the laboratory experience, and this is by data. This is by evidence. So if we want to build the whole ecosystem in Egypt, we have to work on the laboratory experience. And actually, this is not something special about Egypt. The African continent suffer from this. Laboratory experience require instruments, very expensive instruments, require a lot of funding, which may not be available in these countries. This is a quantum effort worldwide, which are 55.7 billion the US dollar by the end of 2025. In Africa, we only have South Africa with declared funding. These are all empty space, including Egypt, of course. We hope this get changed. Today, I'm not going to tell good news. Actually, I am today coming to discuss bad news. Because if we know the bad news, we have a plan. We have a view what we have to fix to correct this in Egypt. In terms of research, because research comes before education. If you have good research, then you have good education. And if you have good education, then you have good industry, right? So this is a landscape about quantum science and technology in Egypt. The data I'm going to show come from SciVal. If you go to SciVal and check for the quantum science and technology topic clusters. Topic cluster is a cluster which contains a lot of topics. You will find 33 topics related to quantum science and technology. And today I'm not talking only about quantum computing. I'm talking about quantum science and technology in general. We have 33 topic clusters in SciVal. These 33 topic clusters are divided to 1,795 topics. So what is the situation of Egypt in these topics? If we check only the topic clusters, you will find Egypt represented in all the topic clusters. Some topic clusters, Egypt has very good contribution in this topic cluster. For example, we have 6 topic clusters. Egypt is ranked from order 5 to order 25. Here order among the countries in the world. So for example, in this topic cluster, Egypt is the 5th country in the world. This is very good, right? In this cluster, Egypt is ranked 17 among the world in terms of the publications produced by the Egyptian institution. Quantum energy and quantum security, Egypt is ranked 17 among the worldwide, the world countries. So we have 6 topics out of the 33 topics with position from 5 to 25. We have 25 topics. Egypt is ranked from the position 26 to 50. I'm dividing them quarters. So in quantum information and optics, which is quantum computing, Egypt is ranked 29 among the world. This is the topic TC9, includes quantum computing, quantum algorithms, quantum circuit, all these topics in this topic cluster. So we are ranked 29 among the world. This is not bad, but not good, right? We are not leading this technology, but we are represented. We have good visibility in this topic. We have 5 topics. Egypt in the order 51 to 75, and we have only 1 topic cluster. Egypt is below 75. And these topics actually are experimental, mainly are experimental topic clusters. So these are the situation in Egypt in terms of the topic clusters. But if we go further and go and look in more details about the topics in the topic clusters, which is 1,795 topics, the situation is completely different. And I'm sorry for the bad news. This is before I go to the topics, this is the order of topic clusters worldwide, and this is the order of topic clusters in Egypt. Just to check if it is aligned with the world approach. I mean by this slide, quantum information and optical state manipulation, which is the first topic cluster, is the highest, is the first topic cluster worldwide. What is the order of this topic cluster in Egypt? You will find it in the 5th place, right? So this is the 5th order, the 5th topic cluster in Egypt in terms of the number of publications. The second topic cluster worldwide is the 7th topic in Egypt. The first topic in Egypt is 13 or 15 topic in worldwide. The order of topics is not aligned with what's happening worldwide. We have to reorder. We have to make research strategy to align what's happening in worldwide with what's happening in Egypt. Maybe we are doing a lot of research in topics which are obsolete. No one is doing research in these topics anymore, right? What's interests people worldwide, we don't do enough work in these topics worldwide. So this alignment is very important. This is some kind of gap analysis to understand the strategy of research if we are doing strategy of research in quantum science and technology. So, but if we go to the topics, this is very bad news. We have 1,795 topics in quantum science and technology. Egypt is contributing only to 349 topics. All the rest of the topics are missing in Egypt. This is good news if you are starting your research and you want to take the lead in this topic. So I recommend you to go and search for some topic with no contribution from Egypt. So you will be the lead in this topic. You are starting this topic in Egypt. If you are taking decision about what topic should be should we work on? I recommend you to start working on topics with no contribution from Egypt, because you are taking the lead now in Egypt in this. You are opening the path for people behind you. So, this, for example, these topics with no contribution from Egypt, all these topics, I'm putting in only sample. Egypt has only contribution in 349 topics out of 1,795 topics. So مش عارف بقى الناس المسؤولين عن البعثات، الناس المسؤولين عن الريسيرش should support these new topics with no existence or no contribution from Egypt. These are the topics worldwide, and these are the topics in Egypt. So this is Egypt, and this is worldwide, and you can see here many topics are missing from the Egyptian side. This is, I'm sorry, I said in the beginning that I'm not saying good news today. I'm saying bad news, so we can correct and make this good news in the future. In terms of education, if you want to develop an educational program in Egypt or anywhere worldwide, we have to decide about the approach on designing this educational program. Usually, the approach is to be disciplinary programs, multidisciplinary program, interdisciplinary program, and transdisciplinary program. What are the differences between these approaches? Disciplinary program is to study, for example, physics or math or chemistry, for example. Only one disciplinary. Multidisciplinary is to study physics, completely physics, and completely math, for example, and completely chemistry. So you are studying some subjects, but you can tell this subject belongs to chemistry, this subject belongs to math, and so on. But I believe in quantum science and technology, in quantum computing, for example, we should take the approach of interdisciplinary when designing the educational program. What is the interdisciplinary programs? The interdisciplinary program is to study, for example, physics, computer science, and some topics in between. You cannot distinguish if this topic belongs to computer science or to physics. Quantum science and technology need some things like this, because many topics you cannot tell if this is computer science or physics or math. It is a combination in the same subject. So this is the best approach, and if we can go to the transdisciplinary approach, it will be much better. But interdisciplinary approach may be enough for the educational program in quantum. In Alexandria Quantum Computing Group, we tried to do this approach over years. In 2005, we developed a PhD level course in Faculty of Science, Alexandria University. In 2007, we started the master level course. Since 2014, we encourage students to do their undergrad projects in quantum computing. In 2021, we started undergrad course in the 4th level. It is elective so far. And we joined the Q Egypt. Q Egypt is an initiative belonging to Q World for educational purpose. Since 2022, we started professional master in quantum science, in quantum computing and quantum informatics. 2023, we started a high school students, and in 2024-2025, we are busy with many things related to IYQ 2025, as I'm going to show you. These are the courses has been developed in Alexandria Quantum Computing Group through years. In 2025, this is a PhD level course, Quantum Circuits and Algorithms. In 2007, quantum computers, in 2021, we started a course in Faculty of Science, Alexandria University, Introduction to Quantum Computers. And in 2022, we started a course in Faculty of Engineering. Maybe Yeah, you studied this course, New Trends, right? It was your first course in quantum computing, and now you are here. We have a course, a full course on YouTube. If you are interested to know more, this introductory course in quantum computing. Through years, we organized summer schools, winter schools. This is our Facebook page. This is a YouTube channel. It contains a lot of educational videos. These are some of the graduation projects that has been developed by the students. Javantam 1, this is a graduation project. This is a simulator in quantum computing. In 2020, some students developed Alex QKit. In 2025, a group in Faculty of Engineering, Abdurrahman was one of them, was the team leader, has been developed Javantam 2. It has many interesting features, such as quantum machine learning, quantum algorithms, export to IBM, export to CERC, export to Penny Lane. If you want to know more about this quantum simulator, you can ask Abdurrahman. He's a mentor here with us. So in 2023, we did a quantum computing program for beginners, for high school students. Some students contributed in science fairs with projects. In 2022, we in Alexandria University, we started professional master in quantum science and technology. It contains some credits mandatory with all the basic contents. So these are mandatory courses. It include all the required background in computer science, math, and physics. Then we have these quantum computing courses. We are starting the third year now in this program. In Almenia International University, we submitted a master program, not a professional master program, but a master program in quantum science and technology. We are just waiting for the approval from the Supreme Council to start this master program. The master program consists of some courses, and the good thing is that you can do your master with thesis or with projects. This is an option in this program. And these are mandatory courses. And these are the elective courses, and you can have 2 tracks. If you are going to computer science track, you will choose quantum algorithms and computational complexity. This is one track. If you are going to physics track, you will choose quantum and reversible circuit design, and you will have a very good list of courses to choose from these elective courses. In 2021, we joined QWorld. It is an educational initiative. QWorld has a very good role in the hackathon. In 2021, we established Q Egypt. If you don't know, and I believe everyone here know about this, QWorld give a diploma in quantum computing, Q bronze, then Q nickel, then Q silver, then Q cobalt, and so on. These are the level of the courses. During the year, we organized many workshops in this. This was the last one in 2025. These are the pages, the Facebook page and the LinkedIn page. We started something new this year, which is a quantum computing summer training for the Egyptian students. It carries the code Q course 110 in the page of QWorld. We started with 506 applicants. We will see after the project, many of these students are here now. So we will see, we started with 506. We will end with how many? Sorry? The last lecture, the assignments, we have about 237 students completed the course, which is very good percent, 50%. This is free, free training for the students from 64 Egyptian students. Also, I'd like to show you something new. It was a very special experience for me. It happened 3 or 4 days ago about educational activities we did in Alamein International University in the context of the Quantum City Prize. This is one of the main events in the International Year of Quantum Science and Technology. The aim of the Quantum City Prize is to bring a quantum to the public. People walking on the street with no plan to listen about quantum computing, we go and talk to them about quantum technology. This is the main aim of the Quantum City Prize. A group of students in Alamein International University showed their interest to organize this. So they organized events in 28, 29 August, just a few days ago, in the streets of Alamein city. Their activities among the 2 days was street interviews. Then the audience will show some simplified version of scientific terms. Then mini games. These are the ideas of the students, not my ideas. These are the ideas of the team contributed to this. Then photo session and testimonies. So their idea was to start with street interview. They go and talk with someone walking on the street. Are you interested in quantum? Do you know anything about quantum? What's your job? Quantum will impact your job these ways in a few years. Then it started with a street interview. Then if this person is interested, he will come to the booth of the event and will pass through 3 stations. In 1-2 minutes, they will introduce them to very simple concepts about quantum computing, like entanglement, superposition, teleportation, and so on. Then he or she will go to the mini game part. The mini game part, these are the ideas from the students. They designed the game, a quantum version from the Snakes and Ladder. You know Snakes and Ladder game? They invented a new version. And actually, this was a very successful idea by them. Many children wanted to play this game more than once. And for example, if you know by dice. So if you go, for example, to teleportation here, then you will jump to teleportation here. And if you go from teleportation here to teleportation here, you will jump. If you go to superposition, you will put your leg. It is just like a plank. So you will put one leg here and one leg here and move in 2 different. So children understand this, and they will have very very funny reaction. For example, when they have decoherence. Or we have measurement, because when they go to the measurement, we ask them a question. If you answer wrong, you will go down 2 steps. If you go correct, you will go 2 steps. So they invented a game for educational purposes, and this is the balance game. Put one leg here and one leg here and try to move in a superposition without falling. I'll just leave you then the photo session, of course, and finally the testimonies. I will just leave you with photo from these events. It was really interesting 2 days. with unexpected reactions from the public. These are the teams, 15 students in علمين International Universities, and it was their effort. So the first day was in المدينة التراثية في العالمين الجديدة in 28th of August. The second day was in الممشى السياحي بمدينة العالمين الجديدة 29th of August, just the last Friday, and I'll just keep quiet and show you some pictures from the event. This is a street interview. And this is the game. So this was a new experience. It showed we didn't expect that reaction from the public. They listened and they were very interested to know more about quantum science technology. We thought that in علمين no one will be interested in quantum, of course, but we were surprised by how many people came to the event. So this is the team of the students, and this is the whole team, including the media staff. Let me show you some. Do I still have time? Dr. Taha, do I still have time? 1 minute. So I'll just go quickly about some future ideas. I hope to see them in Egypt very soon. I have proposal for BSc degree in quantum science and technology. So if you are interested, we can discuss this in the break. This is a whole degree in quantum science and technology. Includes mathematics, computer science, engineering, quantum core courses, and some advanced courses. With this are the number of credits per topic. I have the full proposal, so if anyone interested to implement this in his university, so please we can talk about this. I'd like to thank you very much. I hope it was useful. Any questions?
Yeah, thanks, Dr. Ahmed, and please feel free for anyone who is interested in the new program. I think this bachelor program will open a new era of training to students and everything. Yes, that would be great.
Thank you, Professor Ahmed, for the insightful presentation. I have a question about the statistics that you shared with us about the future job creation. So my question is about the source of the data, if you can share with us.
Yeah, maybe just a comment. Thank you, Dr. Ahmed, for this nice presentation. I find you a little bit harsh with Egypt. Actually, for me, Egypt is doing very well. It's one of the best countries performing in quantum in Africa.
I'm showing statistics to scale up.
I
also
yes.
Would like to see better performance. So that's why I said I will show bad news to know our point of weakness, so we can work on it.
Yeah, I understand that. For me, it's not bad news at all, because I don't think that Egypt or any other country, including mine or any other country, should align with the average of the world or what other countries are doing. There are some specificities. The most important thing is to contribute, to have some strong points to contribute, and not necessarily to contribute in every single one of the 1,800 subtopics. That's
but this gives just an insight about if you are going in the. I believe myself. This statistics shows that if we are moving in the correct direction, we are not going in different directions. So if we see the alignment between the topics in Egypt and topics worldwide, This one, we are not very far. So for example, these green lines, I make it color to be visible. So this green is not very far here, and this color is not very far here. We are very close, but we also always want to make corrections to go to the topics in the world. What's not good for me is that we contribute to little subtopics. 300 topics out of 1,800 topics, I believe we have to work on this because these are hot topics, these are new topics. Maybe no one know about them yet. So this is very good for researchers who are studying their master or their PhD to start look for new topics, not topics that many people did work already.
Thank you for the very rich talk. I'm curious and very interested to see the details of the bachelor program in quantum science and technology, because it looks to me like it's too long of a way to get in a bachelor. The road is too long, because to get a degree in quantum science, put aside the technology, you have to get a lot of physics, mathematics, chemistry, and then you go to the technology, then it requires computing and engineering. It's too much.
These are only 120 credits, which any bachelor degree is 130 or 140 credits. I leave 10 credits or 15 credits for the university electives and all these elective requirements in any. So it is 120 and it covers, I can show you the statistics, it covers by this content about 85% of the job requirements. So we can discuss this more.
Okay, for sure. Thank you.
Thank you. Any more questions?
Thank you for the talk. I wanted to hear if you had any insights about also like taking the efforts towards like an institute that just like focusing on quantum technologies in Egypt, like a scientific institute. Is there some sort of vision for that in your opinion?
What do you mean by focusing on quantum science and technology?
Like, for example, an institute for quantum optics. I know there are a lot of great here Egyptian researchers who are like very good in that. So is there like
quantum optics, as Will City is good in quantum optics. You will not find an institution dedicated for quantum science and technology.
Okay.
But you will find an institution with group very good in quantum optics, very good in quantum machine learning, very good in quantum algorithms. For example, in Alexandria University and in Alexandria Quantum Computing Group, we are focusing on quantum algorithms, quantum circuit optimization, quantum image processing. We are working on certain topics. So if you are interested in certain topic, come and ask me and I'll tell you who to contact.
Okay. Thank you.
Thank you. Any more questions? Thank you very much.
If not, we thank Dr. Ahmed. Thanks, Dr. Ahmed, very much for your nice talk and for all of this nice effort and the nice research works. Now we are going to have our next speaker. So Dr. Murad is a professor of physics at University of Tunis Al Manar, director of the Research Laboratory on Atomic and Molecular Spectroscopy Applications, LSAMA, and coordinator of the Tunisian Quantum Network, Quantum, and the president of Tunisian Metrology Association. Also a visiting professor and researcher at several international universities, including Paris-Saclay, Le Havre, Normandy, University of Sao Paulo, University of South Africa, and Bordeaux University in the United States. Yeah, Dr. Murad, the floor is yours.
Okay. Thank you, Dr. Taha. مساء الخير, السلام عليكم. So first of all, I would like very warmly thank the organizers, Dr. Taha, Dr. Yusuf, and all the team for this very nice opportunity. It's always a pleasure for me to be in Egypt. The topic I will speak about today is just to give you a flavor about the quantum science and technology in Tunisia. I will try to be as concise as possible. So I will start by some general data about Tunisia. Of course, this is more for people from overseas. All Egyptians know very well Tunisia. So about a 12 million population, 13 public universities, roughly 250,000 students. Small numbers compared to a large country like Egypt, of course. 13,000 faculty members, roughly. Most of them are doing research in either laboratories or units. These are official statistics from like 2-3 years ago from the ministry. We aim to reach 1% of GDP for research and development. The number of researchers per thousand of active in Tunisia is 5.7, including more than 50% of female researchers. For PhD studies, more than 10,000 students, and some other figures and data. Maybe one important point is the large part of international cooperation. So more than 50% of the publication are done with partners from different countries. Regarding international ranking, Tunisian universities are doing quite well, especially in some of the well-known ranking systems like Time Higher Education and QS World. For the most known, of course, is Shanghai. So we appear from time to time in Shanghai ranking among the first 1,000 universities. These are the African universities that are among the 1,000 first universities in the world. Of course, the first are from South Africa, but also Egypt is doing very well. In addition to my university, Tunis Al-Manar, and a couple of other universities from other countries. Regarding publications, so let me show you this information in the form of this map. So the map here is a kind of world map distorted according to the number of publication per country. So the area is more or less proportional to the production. So you can see. I don't have a pointer, but you can see on the top that US is dominating, followed by China in red, at right, and then Europe here in the center, and all the African continent is like shrunk to this very small part. But still we can zoom on this part of the map and see that in addition to South Africa and Egypt, Tunisia is emerging and doing quite well, especially per capita. So this is good news, but I agree with Dr. Ahmed that we have to also to look for doing better every time, of course. So some more information for the leading universities in Tunisia, Tunis Al-Manar, but also Sfax, Carthage, and Monastir, by field of research from medicine to life science, mathematics, etc. You can see the topics related to quantum, so mainly physics and computer science. The numbers here are the ranking as well. It's not bad. Can be better, of course. So to be more specific to physics, I'm a physicist, so I will look to quantum physics from the side of physics in addition to what Dr. Ahmed presented as a computer scientist. So for physics, in addition to the universities already mentioned, we have 6 colleges of science, several research centers and institutes. and also active scientific societies and networks. So this includes the Tunisian Physical Society, the Tunisian Society of Optics, the Quantum Network. So Quantum here is the Quantum Tunisian Network, and the N at the end, TUN stands for Tunisia, just playing with the letters here to make something funny. Just to give you one example concerning my university at Tunis Al-Manar, in 2019, we introduced a new curriculum, a master degree in physics, physics and nanotechnology, in which, so I'm showing here the curriculum. So three terms, 3 semesters, and you can see in blue all the lectures which are directly related to quantum. So it goes from advanced quantum mechanics to cold atoms and quantum gases, to quantum information, nanophotonics, nanomagnetism, superconductivity, quantum metrology, and using, of course, for the quantum computing part, the free IBM Qiskit. We are very happy to have access to these resources, of course. So to be more specific about the quantum information lecture, we teach all the basic quantum algorithms, going from Deutsch, Josa, Bernstein, Vazirani, etc., to quantum teleportation, QKD, of course, for communication, Grover, QFT, and QPE for, in red, of course, the most famous algorithm, Shor algorithm, for finding the prime factors in the relation with cryptography. Also, we introduced the variational quantum eigensolver as a possible tool for research, especially in chemistry. Okay, so now for the research in quantum physics in Tunisia, the main topics in which myself and my colleagues are interested in covers themes like theoretical quantum physics, quantum information and quantum computing, condensed matter physics, including quantum dots, quantum materials, topological materials, of course, atomic and molecular physics, optics, photonics, all these themes. I will more concentrate on the themes in blue, which are closer to my own activities. But before that, just to give you an idea about the others, I hope you can see at least the, I'm not sure you can see the names, but at least the topics of the papers. So these are published, for instance, in Physical Review by colleagues. In quantum information and quantum computing, if you are interested in the references, I will leave the copy of the presentation here, so the organizers can share it with you if you are interested in. And you can also ask me, I will provide you with the information. So we have people working on robustness of quantum gates, for instance here, Ghassan Dridi, for instance, to cite the name. Then other people working, so from University of Carthage, working on more, how to say, more fundamental aspects like the collapse and the revival, entanglement, and non-commutative harmonic oscillators, but also more practical topics like using a quantum cloner for the deterministic C-naught gates. So this is typically for quantum computing. Regarding condensed matter physics and the quantum dots, also the community is quite active with several recent publications. I put here some examples of recent publications in very good journals by colleagues. So in quantum, so this was for quantum dots specifically. Then for quantum materials and topological materials, also very good work by colleagues from University of Tunis Al-Manar and also University of Carthage. This is more or less the landscape. I will be now more specific to my lab, what we are doing, and specifically in the field of quantum physics. So I'm responsible for the laboratory of spectroscopic atomic and molecular physics and applications, founded about 25 almost years ago. So the main topics are related to atomic and molecular physics and lasers, plasma physics, experimental physics with lasers, with applications in biology and environment science. Also, strong work in quantum chemistry, like the work presented by Dr. Taha. And in my group, more Rydberg states, called atoms and quantum computing. So, number of publications, the H-index of the lab, and the workforce. So it's quite good lab, actually. So briefly, the topics I will not speak about, but just to mention them: astrophysics and application of lasers in biology, by colleagues here, including very applied physics like studying the quality of oils with the Lips technique. Regarding cold atoms, which are very important in quantum metrology, and also as a candidate for to be a qubit, so for quantum computing. So these are a few references of colleagues from my team and my lab. So covering different aspects, I will very briefly go through them. The main idea is the possibility to manipulate atoms with lasers. So the idea, everyone knows that when we shine a laser on an atom, if the frequency of the laser corresponds exactly to the transition frequency between two levels, you can have an absorption and then emission. This is very basic. So with some more sophisticated physics, the main idea is that with lasers, you can manipulate atoms. What means manipulate? You can trap them, cool them, move them, so manipulate them exactly in the way you want it to be. So here on the right side, you have a kind of cartoon to show with 6 lasers how we can trap a cloud of atoms here from NIST. And this is a photo, this is a picture, a real picture of sodium atoms trapped by 6 lasers, what we call optical molas. I'm not going through equations. It's not, I mean, a specialized scientific talk, but still, what I said is illustrated here. The 2-level system, so G and E, and omega 0 in green is the frequency of the transition, and in red or in blue, the frequency of the laser. I think this will be the only technical slide here. So the idea is that if the laser is detuned towards red radiation, which means that the frequency of the laser is smaller than the frequency of the transition, the atoms are trapped in the maximum of light, the maximum of intensity of light. So imagine I'm shining a laser. Imagine you are seeing here a pointer, a laser, a red dot. Atoms can be trapped in the center of this disk of light. On the other hand, if the laser is detuned towards blue radiation, the atoms are trapped in the minima of intensity, which corresponds to the black region. That's it. So with that, we were able to describe different configurations related to atom optics. So how to use atoms to simulate devices that can be used in atomic interferometry with applications in quantum metrology and even in quantum computing. As an example here, we studied a beam splitter. So everyone knows what is a beam splitter in optics. a beam of light, and then it can be divided into two parts, split it into. The name of splitter comes from that, of course. We do that for atoms here, not for light. So the atoms are split in two beams, and what splits them into two beams is the light. So it's exactly the opposite of what we are used to. So here, a sample of atoms, of rubidium atoms, are trapped at some point, and then they fall in the field of the gravity, guided by the vertical laser. A second laser is shined in a direction with an angle here, and you can see in the picture here that some of the atoms are guided here. So we could split the atom into parts. And we were also able to conduct a detailed study of the dynamics of this process. I will not go into details, but this is the main idea, to split a beam of atoms into parts. Yes, so then came the idea to construct a deflector. Instead of dividing the beam into two parts, deviate or deflect the whole sample of atoms in one direction. This is exactly a kind of byproduct of the first idea. Instead of shining simultaneously the two lasers, we switch on the first one, and when the atoms arrive exactly here, we switch off this laser and switch on this, the second one, so that all the traffic goes to this direction. So we were successful in describing that with the cold atoms, and then with Bose-Einstein condensates. Bose-Einstein condensates are a state of matter we can reach when the temperature is extremely low. So it's a kind of matter wave. Okay. So for that, we have to solve some equations, like the Schrödinger equation everyone had already in physics curriculum and textbooks. Yes, so the deflection of BEC was correctly described. And then we moved to the study of the Bose-Einstein condensates themselves in a specific kind of laser beams, which are hollow lasers. I told you that if the tuning is towards blue, so if the laser is blue shifted, we can trap the atoms in the dark region here. So we proved that for different configurations. Etc. Okay. So including the shape of the sample of atoms from the, let's say, the standard case in 1D, 2D, or 3D, the standard case versus the case where we use the Lagergos lasers. I'm sorry for giving maybe some useless details, but just to put some substance here to show you what we are doing exactly. Then we also studied the effect of the finite number of particles in these specific potentials with some interesting result. Maybe the example I will detail more is the following. Is it possible using cold atoms to test fundamental principles of physics? One of the most known principles of physics is the weak equivalence principle. The weak equivalence principle is the equivalence between the gravity mass, the mass which appears when we take into account the gravity, and the mass which appears in the second Newton law, proportionality between the force and the acceleration. Nothing tells that it's the same mass. It's a principle, it's a kind of postulate, and it is known as the weak equivalence principle, the Einstein weak equivalence principle. How to test this principle? The experiment is very easy. it can be seen as the fact that two different objects with two different masses fall in the field of the gravity exactly with the same speed and reach the ground exactly at the same time. The famous experiment by Galileo from Pisa's tower. Just falling down two objects, one in wood and one in iron, and they fall exactly at the same time. Okay. So this is known as the WEP principle. The idea here is to test it with high precision, not using macroscopic objects, but using very small things, which are atoms. So the Bose-Einstein condensates from the two different species. Here, for instance, potassium and rubidium. Accelerate them vertically to a certain level using lasers, using the interaction with lasers, and then letting them fall in the field of gravity, and with interferometric techniques, check if they arrive exactly at the ground at the same time. Okay, so this is high precision experiment motivated. Yes, so this is the scheme. And it is motivated by experiments done in different countries in the world, where towers like this one, for instance, in Hanover in Germany, more than 100 meters tall. The samples are prepared here, launched vertically in a catapult configuration, and then detected to test this principle. So we were able to provide the experimentalists with a set of parameters that allow them to check the Webb principle to very high precision. As you can see, this is the evolution of the sensitivity or the accuracy of the experiment. We can start here at the beginning, around the beginning of the 20th century, from 10 to the minus 6, the improvement up to 10 to the minus 15. Okay, so far, the equivalence principle is not violated, and this is good news for physics. Otherwise, it will be very complicated. So maybe one last slide on the research, very briefly. This is very recent. The paper is about to be submitted this week on some specific effect in which we show that we can improve the already proposed protocol without using kind of long time. I mean, well, without going into the details, let's say that we found a way to make a kind of shortcut and make the protocol much more efficient. Okay, so this was maybe the hard part in my talk, for me, I mean, because it's quite technical. So regarding now quantum information and the quantum computing, we started first to try to use atoms and molecules and with lasers as a kind of a medium or device to write and read information. So you can see here using 3 lasers for a specific molecule, which is a lithium dimer. We could encode, as you can see here, just integer numbers in binary form. So you can see that we were able to code up to n equals 7 correctly. And more recently, we moved to the use of the variational quantum algorithms application in quantum chemistry. So this is a quite hot topic now in quantum computing. The idea is to calculate the ground state of a molecular system using quantum computing. It's quite easy to obtain this information for small molecules, but it becomes harder and harder for large systems. So what we did with my student Céline, we tried to take a very simple system and compare VQE calculation in green here, the horizontal line in green, and what can be done if we add layers of quantum neural networks in order to improve the quality of the eigenstate we are looking for. You can simply see on this figure that by increasing the number of layers, the blue curve, the blue dots, you can see that the difference with the best calculation decreases, and we can reach the acceptable, commonly acceptable level of accuracy, the chemical accuracy, with 8 layers. So this is very briefly the kind of things we are interested in the lab. So now for maybe the 5 last minutes, let me talk about the outreach activities in quantum. This is the third pillar: education, research, and outreach. So mainly driven by the scientific societies and the networks. So for instance, the Quantum Tunisian Network, Quantum, was founded 3 years ago. Myself and my colleague from University of Carthage, Siam Jaziri. And the idea was immediately to set up a youth branch run by students. And since that time, they are organizing a lot of events in 2022, 23, 24, and this year on the occasion of the World Quantum Day, April 14th. But also, especially this year, as Professor Ahmed mentioned, IYQ 2025. So a lot of conferences, workshops, hackathons also. All this information is available on the social media, the accounts of Quantum Youth Branch, on LinkedIn, on Twitter, on Instagram, on Facebook. You can find them very easily just with the keyword Quantum Youth Branch, sorry. And most of these events were organized in collaboration with the scientific associations in Tunisia. All the activities are also reported in the official site of the World Quantum Day and IYQ 2025. As a recent example of activities, we organized 2 training sessions on Python and Qiskit in February, and then a more detailed training on Qiskit in April of this year. It was quite successful. A lot of pictures on LinkedIn. We joined the initiative of quantum cities as well to be on the map of the world, as Professor Ahmed has shown for Alamein. So Tunis is on the map. You can see it here, maybe hardly at this scale, but it's visible. And Tunis also is part of the initiative of quantum cities in the world, and we also conducted a certain number of activities so that we contribute to the global effort and put our country and our capital on the map of the quantum today and during this year. With this last slide, I would like to thank you very much for your attention.
Thanks, Professor Murad, for your nice talk and nice presentation, highlighting all nice activities and all this impressive work done in Tunisia in quantum. So, anyone have a question? Yeah, please, James.
So, if I'm not mistaken, you had a slide where zeta of 2 appears. Can you go back? It's like in the bottom left corner. There's some. Okay, there's some formula.
You mean the special function?
I think so, yeah.
No.
If you go back, no, further. It's on the bottom
I have
left.
very few equations.
Okay, so okay, you have to go further into the talk, sorry.
Okay,
Yeah,
I will go slowly.
It's on the bottom left. Yeah, you keep going. Unless I missaw it.
Or maybe the Ermakov equation. Not this one.
A little further.
This is simply Lagergos.
Another one. I think another one. That one. Yeah.
Oh, yes.
Is that zeta of 2?
Yes.
I can't see anything.
Yes, it is, yes. Yeah, sorry, I will send you the paper. Yes, it is.
So Yeah, so how is that coming up? How is that arithmetic coming up?
Yes, it appears when you write down the Gross-Kutaevsky equation, and you look for the expression of the critical temperature at which the post-Einstein condensation phenomenon appears. Special functions appears naturally. It's within the format.
So it's arithmetic. It's arithmetic because it's some type of periodic phenomenon or something?
From a math perspective, the energy levels of the electron are inverse squares. And that's where the summation is coming from.
Oh, I see. Okay. Okay, I see.
But you're absolutely right.
Yeah, it's fair, yeah.
It's very elegant, the mathematical formula.
Okay. It's cool because I was recently thinking about the Gross-Kutaevsky parameterization of the Schrödinger equations. Yeah, so.
Gross-Kutaevsky is basically the Schrödinger equation with an interaction term.
Yeah.
As you see, the time dependent or stationary. If I remove this term, non-linear term, it's basically Schrödinger.
Yeah.
This non-linear term, which is specific the signature of the condensation, the interaction section. And if you are interested, I can send you
please.
the full formalism. The first, of course, we didn't invent this. Physics is quite old, but it's very elegant and mathematical.
Okay, yeah, I'll look forward to. Yeah. Cool, thank you. Yeah.
Thanks, Dr. Murad. Does anyone have more questions? Yeah. Okay. If not, then we can resume the questions in the break. Thanks, Dr. Murad again.